All right, this is Unit 2, Lesson 1 of our calculus class, the new second unit. Unit 2 is called Derivatives. Lesson 1 is called Average Rate of Change and Secant Line. And just a quick, what we're doing the next two lessons is to kind of build up our conceptual understanding of derivatives. So in this lesson, we will define average rate of change over an interval, and we'll talk about how does a secant line relate to average rate of change. So average rate of change refers to the, well, like the name suggests, the average rate of change over some interval. So if we can write this, basically our slope formula, change in y over change in x, we can write it in two ways that are helpful for us in calculus, also known as the difference quotient, it's a slope formula. So if we have some value of a, f of x minus f of a over x minus a, our interval would be a to x. The way that we're going to look at it more commonly for the next couple weeks is this way right here. So if we have an interval a, and then the interval is some value h wide, then the end point of this interval is a plus h. So our interval is from a to a plus h. Our slope function, or our difference quotient, could be written as f of a plus h minus f of a over a plus h minus a. And so that represents our average rate of change given whatever the a and h values are, our interval. And also, we can look at the graph and see that this makes our beginning point and our end point of our intervals. If we connect those dots and draw a line through them, it creates what we call a secant line. I think basic Latin of secant line is a line that cuts through something. And so the secant line is going to cut through our graph at a, and it's going to cut through our graph at a plus h. All right. So we could find average rate of change from a table. If given some bizarre as it may be, some table of information, gallons of saliva, really. So the gallons of saliva can be written as a function s of t, t being the number of years since 2010. So in 2010, apparently 6 gallons of saliva were collected. And if t is 2, that's 2012, there were 17 gallons. So that means 11 gallons plus the 6 gallons they had in year 0, or 2010. And then in 2016, they had a total of 38 gallons, which is mind-boggling to imagine 38 gallons, let alone 57 gallons of saliva. Anyways, the question says the average rate of change in the amount of saliva between 2012 and 2019. So 2012, that would be t equals 2. 2019 would be t equals 9. So our interval is from 2 to 9. Our outputs, s of 2 is 17, and s of 9 is 50. So we could write s of 9 minus s of 2 over 9 minus 2, which would be 50 minus 17 over 9 minus 2. And it would be units of gallons per year. Quick note on our math right here. So I do want to evaluate the function notation for their numerical values. But once I have the numerical values, I don't really care about simplifying the arithmetic so much. And so reason being is this is a calculus class, not an arithmetic class, not an algebra class. We will have to do some arithmetic and algebra to find answers for calculus questions, but subtracting whole numbers like this, we're not going to waste our time. We can just leave our answer like this. If this was an AP test, the scores don't go down if you simplify or don't simplify. In fact, if you do simplify but you make a simplification error, they will dock you points on the AP test. So to be consistent with that as well, we're just going to leave our answer like such and say this is done, let's move on. Okay, so here's another average rate of change question. Given a formula, so the number of bunnies is a function of time, and so t, I guess, would be 2,000 how many years after 2000. So if we go from 2004 to 2022, how many bunnies are we, what's the average rate of change in the number of bunnies we got going on? So intervals from 4 to 22, if we plug in b of 22 and b of 4, we get this function right here. B of 22 minus b of 4 over 22 minus 4 would be our setup for our average rate of change. We evaluate, so 22 squared plus 2 minus 4 squared plus 2 over 22 minus 4. And again, we have our numerical values set up in this difference quotient, so we are not going to bother simplifying any further. And don't forget our unit of measure, bunnies per year. All right, some examples of what our homework will look like. So tangent line problem. The graph y of f of x is graphed here in black. The average rate of change over the intervals given in A, B, and C all create different secant lines. So let's see here. So the average rate of change from -6 to -1. We're going to find -6 is right here, -1's down here, so we see we have a negative slope. We do f of -1 minus f of -6 over -1 minus -6. And we can actually evaluate this. The average rate of change on this interval is -4. So B, our interval is -7 to 4. So that's this blue line right here is our secant line. The slope of this secant line is the average rate of change on this interval. And so we could evaluate f of 4 minus f of -7 over 4 minus -7. Evaluate for our numbers, we can get a simplified answer of 10. And if our interval is -4 to +4, we get this red secant line. And the slope of this secant line is our average rate of change. It should be 30 over 8. Okay, so here's another way to look at it. And this is using our notation f of a plus h minus f of a over a plus h minus a. And so a is the beginning of our interval, and h is the width of our interval, and a plus h is the endpoint of our interval. So as we look at this problem, h is an increasingly smaller interval. So if we want to find our interval from -1 to -1 plus h, if h is 1, our interval is -1 to 0. If h is 0.1, our interval is from -1 to -0.9. And if we do h of 0.01, our interval is -1 to -0.99. And for the last h value, our interval is -1 to -0 and 999 thousandths. So if we take a look at that, we can evaluate each of those points using our formula. So we would have f of 0 minus f of -1 over 0 minus -1. We'd have f of -0.9 minus f of -1 over -0.9 minus 0.1. We can also use a calculator to simplify these for us. And we can do the calculations from there. Anyways, the takeaways from this video: the average rate of change over an interval is something we can calculate. On a graph, this appears as a slope of a tangent line over any given interval. And a secant line is just a line that cuts through the graph at the two interval endpoints. And we have a definition here we're going to use for our average rate of change. And we're going to use this definition in our next video, instantaneous rate of change.